Hello my dear students, now we'll answer a final geometry exam. Question number 1. Choose the correct answer. Find in the cyclic quadrilateral each two opposite angles are supplementary. 2. A square is of perimeter 20 centimeters, then its area equals 50 centimeters squares, 50 centimeters, 25 centimeters square, 25 centimeters. The perimeter of a square equal by side multiply 4. We want to find the side. Put 4 in the other side by dividing perimeter dividing by 4. Side equal 20 over 4. The result is 5. The side length equal 5 centimeters. Then the area of a square equal area of square equal side multiply side equals 5 multiply 5 equals 25 centimeters square. The choice is 25 centimeters squares. Question 3. Triangle ABC is right angled at B. If BC equal 8 centimeters, AB equals 6 centimeters, then sin C equals space. Here we must draw a right angled triangle at B. ABC, right angled triangle at B. Put the length of each side. BC equal 8 centimeter, AB equal 6 centimeter. We want to find sin C. Sin C equal opposite over hypotenuse. The hypotenuse is not exist. Then we use the Pythagoras theorem to find it. AC all of power 2 equals AB all of power 2 plus BC all of power 2. 6 power 2 36, BC power 2 8 power 2 equals 64. Then the result is 100. Then AC equal the square root for 100 equal 10 centimeter. Sin C equal opposite over hypotenuse, then 6 over 10. In the simplest form, 6 divided 2 equal 3, 6 divided 2 equal 10 divided 2 equal 5. Then the choice is 3 over 5 equals 0.6. Number 4. The ratio between the measure of the central angle and the measure of the inscribed angle subtended by the same arc equal. هنا قال لنا central angle in the first and the inscribed angle in the second. The ratio between them is 2 to 1 because the inscribed angle equal half the central angle. But here the first is central angle, not inscribed angle. Okay? Number 5. The measure of the angle of the regular pentagon is equal to. Pentagon consists of 5 sides. Okay. To find the measure of each angle in regular pentagon, we use the rule n minus 2 multiply 180 over n, where n is the number of sides. 5 minus 2 equals 3. 3 multiply 180 divided 5. 3 multiply 180 equals 540 divided 5 equals 108. Last question. A chord with length 8 cm in a circle with circumference 10 by centimeter, then it is distant from its center by. عشان نجيب it distant from the center, we must have a radius. To find the radius, we'll substitute in the circumference of the circle. The circumference of the circle equal 2 by r. The circumference of the circle is 10 pi equals 2 multiply by multiply r by, remove with r, with pi. We'll put 2 on the other side by changing the sign. Here multiply, here dividing. There r equals 5 centimeter. The radius is 5 centimeter. To find the distance between the chord and the center, to explain this, we will draw a circle like this and we'll joining these 2 points. This is a radius, we get 5 centimeter. To find the distance between the center and the chord, we must be the side is perpendicular. This perpendicular to and bisects the chord 4 and 4, 2 equal parts. 5 Pythagoras theorem. 5 power 2 minus 4 power 2, 5 power 2, 25 minus 4 power 2, 16. The distance is 3 centimeter. So the distance from the center to the chord is 3 centimeter. Question number 2a. AB and AC are two chords equal in length in a circle M. X and Y are the midpoints of AB and AC, respectively. Measure of angle MXY equal 30. Prove that triangle MXY is an isosceles triangle. First, we must draw the figure. Circle like this. AB and AC are two chords equal in length. AB, AC are equal in length. X is the midpoint of AB. Y is the midpoint of AC. Measure of angle MXY equal 30 degrees. Prove that triangle MXY is an isosceles triangle. Okay. Number 1. Here he said AB and AC are two chords equal in length. Okay. Number 2. X and Y are the midpoints. Since X is the midpoint of AB, therefore MX perpendicular on AB. Since Y is the midpoint of AC, therefore MY perpendicular on AC. Since AB equals AC, therefore MX equal MY from the theorem. The chords are equal, then equidistant from the center of the circle. MX equal MY, therefore the triangle MXY is an isosceles triangle. Question number B. In the opposite figure, AF is a tangent to the circle at A. AF parallel to DE. Prove that DEBC is a cyclic quadrilateral. AF is a tangent and AB is the chord in the circle, so the angle between them is called angle of tangency. The angle of tangency equal the angle of inscribed angle subtended by the same arc. Then the measure of angle FAB equal measure of angle C. Number 1. Number 2. Since AF parallel to DE, therefore measure of angle FAB equal measure of angle AED, alternate angles. Since measure of angle AED equal measure of angle C, exterior equal the opposite of its adjacent, therefore the shape ABCD is a cyclic quadrilateral. To write it, since AF is a tangent, AB is a chord, then therefore angle FAB is an angle of tangency, since in the angle ACB is an inscribed angle subtended by the same arc with angle of tangency therefore measure of angle FAB equal measure of angle C. Number 1. Since AF parallel to BC, DE, and AE is a transversal, therefore measure of angle FAE equal measure of angle AED نسميها number 2 alternate angles from 1, therefore from 1 and 2 measure of angle AED equal measure of angle C. Therefore DEBC is a cyclic coed because the measure of angle AED exterior equal the opposite to its adjacent. Okay. Question 3a. In the opposite figure, a circle of center M, measure of angle PMC equal 100, measure of angle ABD equal 120. Find measure of angle DCB. Measure of angle ABD equal 120 and measure of angle BMC equals 100 degrees. Measure of angle BMC is a central angle and measure of angle angle BDC is an inscribed angle subtended by the same arc. Therefore measure of angle BDC equal half measure of angle BMC. So measure of angle BDC equals 50 degrees. The measure of angle ABD equal 120 and the angle ABD is an exterior angle for triangle DBC. We studied before the exterior angle equaled the sum of two interior angle excepted the adjacent angle. So measure of angle ABD equal measure of angle BDC plus measure of angle BCD. So measure of angle BCD equals 120 minus 50 equals 70 degrees. So measure of angle BCD equals 70 degrees. Since angle BMC is a central angle, angle BDC is a inscribed angle, therefore subtended by the same arc, therefore measure of angle BDC equal half measure of angle BMC. 1/2 multiply 100 equals 50 degrees. Okay, since angle ABD is an exterior angle of triangle DBC, therefore measure of angle ABD equals measure of angle D plus measure of angle BCD. Measure of angle ABD equals 120, measure of angle D 50 degrees plus measure of angle BCD. We put 50 in the other side by changing the sign. Measure of angle BCD equals 120 minus 50 equals 70 degrees. Question B. In the opposite figure, AD is a diameter in the circle M. CA and CB are two rays tangents to the circle M, touching it at A and B, respectively. Prove that measure of angle DMB equal measure of angle ACB. Here, AC ray is a tangent drawn from the end point of a diameter AD, therefore MA is perpendicular on AC, therefore measure of angle CAM equal 90 degrees. By the same way, CB is a tangent, MP is a radius, therefore CB is perpendicular on MP, therefore measure of angle MPC equal 90 degrees. Since measure of angle CAM plus measure of angle CPM equal 180 degrees, therefore the figure ACBM is a cyclic quadrilateral. From the properties of cyclic quadrilateral, since in the angle BMD is an exterior angle, therefore the measure of the exterior angle equal the opposite to its adjacent, then therefore measure of angle BMD equals measure of angle C, opposite to its adjacent. Okay, to write it first, since CA is a tangent AD is a diameter, therefore CA perpendicular on AD, therefore measure of angle MAC equals 90 degrees. Number 1. Since CB is a tangent, MB is a radius, therefore MP perpendicular on CB, therefore measure of angle MBC equals 190 degrees. Number 2. From 1 and 2, their sum is 180 degrees. Therefore, the figure ACBM is a cyclic quad. Since angle BMD is an exterior angle to the quadrilateral quad, therefore measure of angle BMD equal measure of angle ACB. Okay, another question. 4a. In the opposite figure, ABC is a triangle inscribed in a circle. AD is a tangent to the circle at A. X belongs to AB. Y belongs to AC, where XY parallel to PC. Prove that AD is a tangent to the circle passing through the points AX and Y. Okay. He said AD is a tangent. Okay. Therefore, DAB is angle of tangency. Since ACB is an inscribed angle draw subtended by the same arc with angle of tangency, therefore are equals. DAB equals C. Number 1. Number 2. XY parallel to PC. Therefore, measure of angle C equal measure of angle AYX corresponding angles. So, number 2, from 1 and 2, DAB equals AYX. Therefore, AD is a tangent to the circle passing through the points AX and Y. To write it, since AD is a tangent, okay, therefore angle DAB is an angle of tangency. Angle C, angle ACB is an inscribed angle therefore measure of angle DAB equal measure of angle ACB. Okay, number 1. Since XY parallel to PC and CY is a transversal. Therefore, measure of angle AYX equal measure of angle ACB, corresponding angles number 2. From 1 and 2, measure of angle DAB equals measure of angle AYX YX. Therefore, AD is a tangent to the circle passing through the points A, X, and Y. Question P. In the opposite figure, ABC is an inscribed triangle inside a circle. DE parallel to BC. Prove that measure of angle DAC equal measure of angle BAE. Since DE parallel to BC, therefore the measure of arc BD equal the measure of arc AC. Okay, therefore the inscribed angles drawn on it are equal in measure. Therefore DAB equal measure of angle EAC. By adding measure of angle BAC to both, the result DAC equal measure of angle BAE. This is a first solution. Another solution, since DE parallel to BC, therefore measure of arc BD equals measure of arc CE. Okay? By adding measure of arc BC to both, therefore measure of arc DBC equal measure of arc ACB. Then the inscribed angles drawn on it are equal. Therefore DAC equals BAE. We will write, since DE parallel to BC, therefore measure of arc DB equal measure of arc CE. By adding measure of arc BC to both, therefore measure of arc DBC equals measure of arc ACB. Therefore measure of angle DAC equal measure of angle BAE, and this is required. Question 5. In the opposite figure, AB ray and AC ray are two tangents to the circle at B and C. Measure of angle A equals 70. Measure of angle CDE equal 125. Prove that CB equals CE. Okay. Since AC and AB are two tangents drawn from the point outside the circle, therefore are equal in length. then the triangle ABC is an isosceles triangle. Therefore, measure of angle B equals the measure of angle C. Since the measure of sum of angles of the interior angles of triangle equals 180, therefore measure of angle CBA equal measure of angle ACB equals 180 minus 70 divided by 2. 180 minus 70 equal 110 divided by 2 equal 55 degrees. Since angle CBA is an angle of tangency, angle CEB is an inscribed angle, therefore measure of angle CBA equal measure of angle CEB. It's okay. Since the vertices of quadrilateral DCBE lying on the circle, therefore DCBE is a cyclic quadrilateral. Since measure of angle D equal 125, therefore measure of angle B is supplementary to it. So measure of angle B equals 180 minus 125 equal 55. Okay. Since in the measure of angle CBE equal measure of angle CEB, therefore CB equal CE. This is a first required. The second required, AC parallel to BE. AC parallel to BE. Since in the measure of angle ACB equal measure of angles in the form of alternate angles, therefore AC parallel to BE. It's very easy. Since AC, AB are two tangents, therefore AB equal AC, therefore triangle ABC is an isosceles triangle. Okay, therefore measure of angle ABC equal measure of angle ACB equal 180 minus 70 over 2 equals 55 degrees. Since angle ABC is an angle of tangency, angle CEB is an inscribed angle, therefore measure of angle ABC equal measure of angle CEB equal 55 degrees. Since C, B, E, D lie on the circle, therefore CBED is a cyclic quad. Therefore, measure of angle D plus measure of angle CBE equals 180 degrees. Therefore, measure of angle CBE equal 180 degrees minus 125 degrees equal 55 degrees. Since measure of angle CBE equal measure of angle CEB equals 55 degrees, therefore CB equal CE. Since in the measure of angle CBE equal measure of angle ACB equals 55 degrees in the form of alternate angles, therefore AC parallel to BE. Okay,